Okay, so you've written the code. It looks fantastic running locally on your machine, but that's really only half the battle, isn't it? Our deep dive today is all about that next step, getting your Lightning Web component moved, from your safe little sandbox into a live Salesforce org. And crucially, making sure it actually performs the way it should throughout its entire life on the page.
Exactly. We've basically got two key missions here. First, how do we deploy this thing reliably like professionals? And second, we need to really understand the component's own internal checkpoints. These are the lifecycle hooks. They control everything from the moment it appears to the moment it vanishes.
Right. Let's tackle deployment first because, look, we know the modern standard is the Salesforce CLI, SFDX, usually working through VS Code. But you still hear about admins using change sets quite a bit. Is there a real downside to sticking with those sort of manual bundles instead of SFDX for development?
Oh, absolutely. The biggest danger, it's the lack of version control. It really is. SFDX, especially when you pair it up with tools like Git, maybe CI/CD pipelines, it means every change you push is tracked. It's auditable. You can roll back if something goes wrong. It supports team collaboration. Change sets are just, they're manual copies. There's no history, no easy rollback. SFDX deployment is structured, professional. That's the real benefit, the safety net it provides.
Got it. Okay, so version control is key. Foundational, really.
Mm-hmm.
Now, even before we think about running that ESF project deploy start command in the terminal, what's the one technical step you absolutely positively cannot forget?
Yeah. You must configure the component's metadata file, the js-meta.xml one. And this isn't just like a suggestion. It's vital for security and just .control. You have to set is exposed to true. That's what makes it even show up as an option in the Lightning App Builder. And maybe even more important, you need to define the targets. So telling Salesforce specifically where it's okay for this component to live, like on a Lightning record page or whatever, without that, you've basically got no control. It's just loose code.
Okay, that makes sense. So SFDX gets the code files up into the Salesforce cloud.
Yeah.
But that doesn't mean users suddenly see it, right? There's still a manual bit.
Exactly right. Deployment gets the code to the org, but then you, the admin or developer, have to go into the Lightning App Builder. You physically drag your new component onto the page layout where you want it, configure any properties, and then you hit save and activate. That's the final step to make it live for users.
Right, the App Builder step. Can't forget that.
And that moment you click save in the App Builder, that's basically when the component comes alive in the org. Which brings us perfectly to our second mission. Those internal checkpoints, the lifecycle hooks. This is how you manage what the component does while it's alive. Fetching data, cleaning up resources, interacting with the page. It's all governed by these hooks, essential for performance.
Okay, let's break them down. Where does the component's journey technically begin with the constructor, right? What happens there and what's the first big don't?
Yep, the constructor fires absolutely first before anything else, but it's extremely limited in what you should do there. Really only use it for setting up very basic internal component state, things that aren't reactive properties. And the huge warning, the big don't, is you never try to access the page's DOM here, and you absolutely cannot make calls to Apex or use the wire service. The component simply isn't connected to the page yet.
Okay, no DOM, no Apex.
Yeah.
So given that limitation, when is the actual first chance we get to, say, call an Apex method to fetch data? Or maybe hook up a wire adapter?
That's precisely the job of the next hook, connected callback. This one fires right after the component gets inserted into the actual DOM structure of the page. This is your prime time for data loading, fetching data from Apex, using the wire service. Do it here. It's also the right place to set up things like global event listeners if you need them.
Okay, connected callback for data. Makes sense. So data arrives, component updates, and it renders on the screen. Then we hit rendered callback. This one always feels a bit tricky. High potential for mistakes, maybe.
It is high stakes, yeah, because it doesn't just fire once. It fires after every single time the component or even its child components finish rendering or re-rendering. So it's the place if you need to interact directly with the rendered DOM. Maybe you're initializing some third-party JavaScript library that needs a specific DOM element.
Yeah.
But here's the trap. If you modify a reactive property inside rendered callback, what happens?
Uh-oh, that triggers another re-render, right?
Exactly, which then calls rendered callback again.
Which modifies the property again. Oh, I see. An infinite loop. I bet that just freezes the user's browser, doesn't it?
Total performance meltdown, catastrophic failure for the user experience. So the rule is, You must use some kind of conditional logic. A simple Boolean flag like if this dot has rendered, set it to true after the first run. That way your sensitive DOM manipulation or setup code only executes once after the initial render, not every single time. Prevents that loop of death.
Okay, critical guardrail there. Use a flag, got it. Now, the hook that maybe gets overlooked the most, but you're saying is vital for long-term health. Disconnected callback.
Absolutely vital, and yes, often forgotten. This hook fires when your component is removed from the DOM. Maybe the user navigates away or deletes it from a record page, whatever. Its job is cleanup, it's mandatory. If you set up any event listeners back in connected callback, or maybe started a timer with set interval, you must remove them here. If you don't, you create memory leaks.
Memory leaks. Can you quickly define what that means in like practical terms for someone listening?
Sure. Think of it like this. The component UI is gone from the page, but because you didn't clean up, its event listener is still hanging around in the browser's memory listening for an event that might never happen again. Or a timer is still ticking away in the background. It's like a zombie process. Consuming browser resources, consuming Salesforce server resources potentially, long after it should be gone. Over time, this drags down performance for the entire org, silently.
Yikes. Okay, so cleanup is non-negotiable. So one more hook.
Just one more main one, error callback. This is your safety net for errors that happen within your components, child components during their life cycle. It lets you catch those errors, maybe log them, and display a nice user-friendly error message instead of just breaking the page, kind of like an error boundary.
Okay, that's a good overview. So boiling it all down, the core message for developers listening seems to be twofold. One, use SFDX for deploying your code. It's professional, it's trackable, it's safer. And two, master those lifecycle hooks, especially connected callback for getting your data in and its counterpart disconnected callback for cleaning up properly afterwards.
That's a great summary. And if you want the sort of deeper takeaway, the provocative thought to leave you with, it's that just making the LWC work isn't enough. That's just table stakes. Truly understanding why you need disconnected callback, why that cleanup is critical. That's the mark of a professional. That discipline is the difference between building a component that functions today and building one that contributes to a healthy, performant, efficient Salesforce environment for the long haul. Resource management isn't flashy, but it's absolutely essential.